Alright, this is Algebra 2, Chapter 3, Section 3, Solving System of Inequalities. One way you can solve a system of inequalities is by creating an X table. So in the example that they give us, we have g plus m is greater than or equal to 6, and 5g plus 2m is greater than or equal to 20. What you can do is you can plot a chart. They use 5g and 2m, and they plugged in 0 for g. So then you plug in 0 for g, and you have a 2m is less than or equal to 20, divide by 2, you got m is less than or equal to 10. So if you look over here, and they're doing whole numbers, you have 0 over here for their g, and you have everything less than to 10 up to 0. So they go 10, 9, 8, 7, 6 all the way up to 0 because it's less than or equal to 10. Then for 1, it's less than or equal to 7. For 2, it's less than or equal to 5. For 3, it's less than or equal to 1. And for 4, it's less than or equal to 0, and they go to 0. In the second part, they do the same thing, but now they do it for the other equation. And what you can do is you can highlight or circle, or however you want to do it, the sections where they overlap. And those would be the solutions for those two inequalities. So you can chart a graph, plot a bunch of points, and then set them in. Pretty inefficient. I'm not going to do that because nobody does it that way. But you could just plot the points, and you can do it from 0 to 0. 0 on the x to 0 to the y. And that it works out pretty well. Actually, I guess I can do it. So if I was to do it, this is for 3x plus 7y less than or equal to... I changed my mind, I'm not going to do it. You can plot the points yourself. You guys know how to plot points. This is what I care more about. Solving a system and inequality by graphing. So, here two inequalities, and we can graph them. The first thing you can do is put them into a y-intercept form. So here we have 2x minus y is greater than or equal to negative 3. So you subtract 2x from both sides. You have negative y is less than or equal to negative 2x minus 3. Multiply times negative 1, you have y is greater than or equal to 2x plus 3. Notice that it says y is greater than, right? So, or less than. Y is less than. So when I look at these again, since I see less than, I'm going to base everything off the y, where it intersects the y-intercept. When it intersects the y-intercept, we have a solid line, and we're going to go in the downward direction since it's less than. So I'm going to shade everything less than. Then, for the other one, we already have y greater than negative 1/2 plus 1. Again, a solid line or equal to solid line. Go where y intersects, the line intersects the y-intercept, the y-axis. And you're going to go up. You're going to go up. And then when you graph both of these guys and superimpose, where they are both existing at the same time is the intersection right there. And it would be right there in the green, light green. Pick a point where they overlap. When you pick a point where they overlap, it should work out for both scenarios. You plug in that point. In this case, it looks like they used 0, 2, right here, and I put it on the line, and they should both work out for both. Okay, so let's see what this looks like. So I'm going to use decimals for this. So here we have x plus 2y less than or equal to 4. I'm going to subtract x from both sides, so it's going to be 2y is less than or equal to negative x plus 4 divided by 2. I have y is less than or equal to negative 1/2 x plus 2. That's my first equation, and my second equation is going to be y is greater than or equal to negative x minus 1. Okay. Negative x plus 2 . Okay. And the other one was what? Y is greater than negative x. Oh, negative 1/2 x. That makes a difference. Alright, y is greater than negative x minus 1. Okay. So when you graph these here and here, we have our overlap. Our overlap is right here between these two guys. So you can pick a point. You can pick 0, 0, and it should work out for both. And then you have your intersection point. And make sure that your graph is correct. So 0, 0. So if I plugged in 0, it's number 2. It's number 1. So if I plugged in 0 for x, it should work. So for the first example, 0 is less than or equal to negative 1 plus 2, so we have 0 is greater than or equal to 2, so that works. Or 0 is less than or equal to 2. Then for the second one, we have 0 is greater than or equal to negative 0 minus 1. 0 is greater than or equal to negative 1, which is true, so that works. So that shows me that the graph is correct. Alright, and then we give us a word problem. Here it says a pizza parlor charges $1 for vegetable toppings and $2 for meat toppings. So $1 for vegetable toppings. So we could just say 1V plus $2 for meat toppings. And we have $10 to spend. So that's going to be less than or equal to $10. And then we have says you have at least 5 toppings on your pizza, at least. So let's do it like this: 1x plus 2y equals m So, and then we have to have at least less than 5, so y has to be less than or equal to 5. There we go. So then turn this into slope-intercept form, and we have y is less than or equal to -1/2 x plus 5, and then y equals 5. And then the intersection is the different types of toppings, combinations of toppings that we can put on our pizza. So if we were to do that, 1fx plus 5, how convenient, and then less than 5. There we go. Their intersection would be all the points where all the toppings of the pizza that we can have. So if I was to pick a random spot, of course that makes sense. Less than 5 over to 10 because it'd be less than $10. Say we can do 1 and 2, or 1 and 1. This is 1, 2, and 1. So 2 and 1. Let's give that a go. So say 2 and 1. Well, for the first part, we put this is -1 plus 5, which is 4, so that works. And then for part 2, that definitely works because 1 is less than or equal to 5, so that works. So I can have 2 veggie toppings and 1 meat toppings, and it would satisfy that condition based off of the graph. I can also solve linear equations of nonlinear systems. In this case, we're going to use the linear equation in the absolute. And here I have y equals -1/3 x plus 1. It's going to be a dotted line, and it's going to be going in a downward position and has a y-intercept of +1. So -1/3 x plus 1. -1/3 x plus 1. There. And L was the absolute value. So absolute value of 2 absolute value x minus 1. Alright, a very small intersection. So, so y is greater than is greater than, there we go. So here's our intersection. This is 0, 1. Go up here and this is 2. This would be 1. So this would be 1/2. 1 and 1/2. So the solution would be 1 and 1/2. So if I was to put yeah, 1, 1/2. To confirm that it's correct, plug in 1/2 is less than negative 1/3 times 1 plus 1. So 1/2 is just greater than negative 1. So 1/2 greater than 2/3 or less than 2/3. So this is 3/6. And this is 4/6. So that checks on that side. On the other side, we have same thing, 1/2 greater than 2 absolute value of x minus 1, which is 1/2 greater than 2 times absolute value of 0. 1/2 is greater than 0. So this also checks. So that tells me that the graph that I set up is correct. Okay. So that's this section. All you're doing is graphing and checking to see if their overlap is correct. Have a great rest of your day.